Radar remote sensing has progressed tremendously over the past several decades, from massive air control and defense systems to compact portable devices. Many emerging technologies, such as unmanned aerial vehicles and autonomous cars, utilize radar systems for sensing their environment. These technologies utilize electromagnetic signals for radar sensing, as well as for wireless communications with remote operators and neighboring devices. The need to transmit both radar signals and wireless communications from the same device motivates their joint design as a dual-function radar communication system. Designing these functionalities jointly can significantly facilitate their simultaneous operation. MAJorCom operates as a new strategy to use radar waveform for conveying information. The underlying rationale is to embed information bits into the parameters of the waveform using index modulation. The MAJorCom system prototype has been implemented using over-the-air signals. In order to generate radar targets, we are using a radar echo generator. The waveform is transmitted through a channel to the generator, which then generates targets with controllable velocity and range and sends the echoes over the air to the antenna.
Welcome to this demo on MAJorCom, where we demonstrate a dual function system that acts as both radar transceiver as well as communication transmitter. We consider a 16-element antenna array where 8 elements acts as a transmitter and 8 elements acts as a receiver. To begin with, we generate a dual function waveform that has both radar transmission signal as well as a communication information. The signal is generated through a MATLAB inner system, and the digital samples are converted to analog signal using TX FPGA. Once the signal is converted to analog waveform, it transmitted through a 8-element antenna array. The transmit signals are received through 2 sets of antennas. One set of antenna elements acts as a communication receiver. The received signal are taken to a RX FPGA, down converted and converted to digital samples. And from the digital samples, the information bearing part is extracted. The second set of antennas are acted as a radar echoes, where once the signal is received, it uses an echo generator to transmit back some signals. These transmitted signals is received through remaining set of 8 receiving antenna elements. Once the signals are received, they are taken to another set of RX FPGA and converted to digital samples. And from those digital samples, the location of these radar echoes are estimated.
Here, we are launching an experiment of the system. First, we feed a target map into the radar echo generator. Then, we transmit a waveform and process the echoes. Now, we modify the target's parameters that are induced by the echo generator. We then add noise to the radar echoes in the software. And finally, we process the received signal and add different noise levels in the software. To conclude, MAJorCom provides joint radar and wireless communication capabilities in which radar performance is not affected due to the need to communicate, and the implement is feasible and simple as demonstrated in this video.